The diagrams show 4 sets of apparatus A, B, C, D. Which set of apparatus would be most suitable to determine the boiling point of a liquid? So how would you determine the boiling point of a liquid? You're gonna need to boil it, okay? Meaning the liquid is going to be gas, right? Like how else can you determine the boiling point? You bring a liquid, you boil it, you allow it to become a gas, and then what you have is insert a thermometer and you see what is the temperature that's shown on the thermometer, right? Now, here's the thing. Typically, if the thermometer is inserted inside the liquid, the temperature is not very accurate. However, you don't really have to know this, okay? So even if you pick apparatus D, it's fine. They're going to accept it for you. The answer here is B, because it's best to have the thermometer just above the liquid so that it's reading the vapor right above the liquid, which is going to be exactly at boiling point. So if it's 100, it's going to be exactly at a 100. If it's water, it's going to be exactly at 100. But here's the thing. So B is the correct answer. D would be accepted. Now, question, why is A and C wrong? Now, A and C are completely shut down test tubes with no side arm, no openings, no place for the gas to escape. So what you're doing here is you're boiling the liquid. It's going to be a gas right here, and you're keep increasing the temperature, right? Because you're boiling here. And this gas is going to be hotter and hotter and hotter. And what happens when the gas becomes hotter? It moves faster, right? Because it's hot. The temperature is high. It moves faster randomly in all directions. And when that happens, pressure increases. All right. So what happens when pressure increases? The bung will flow out, will just, be expelled, or the test tube will break. Have you ever, I'll give you an example. Have you ever had a container closed well with food or soup or something, and you put it in the microwave for way too long? You put it for a crazy 5 minutes. All right. What happens? This lid pops out, right? And if your container is of a bad quality, it may break. Okay, that's exactly what happens. Why? Same idea. You're evaporating the liquid. The gas inside here, let me represent the gas with another color, okay? So what happens here is that the liquid is evaporating. All right, it's changing from liquid to gas. So what you're having here is more gas, more gas, more gas, more gas, more and more and more particles. And these particles are moving faster and faster and faster. So what happens here is that pressure keeps increasing until one or the other, until the lid pops out or your container explodes. Okay, so it's kind of actually dangerous to do that in the kitchen. I hope you don't. I've certainly had that happen before in my kitchen. All right, many accidents, yes. What would be the effect? Oh, so that's why B and D are the correct. Indicate an arrow on the diagram where heat is applied. Okay, so I usually have students write this correctly. So the heat will be applied at the bottom, right? Now, I cannot imagine a student deciding to heat from sideways or up there, like, right? Yeah, it's always at the bottom, right? So I mean, if you use the kitchen maybe once, then you will know. What would be the effect if liquid in A was heated strongly? So they're talking about the scenario where you're heating a completely closed container, like no place for the gas to escape. Now, the good thing about B and D is that the gas can escape. So the pressure will never build. The gas will just keep escaping, right? So the effect is the test tube may explode. The test tube will explode, or you can say that the bung will fly off. It will just pop out. Okay. But if you cannot think of the word of fly off or pop out or something similar that the examiner will understand, you can just say the test tube will explode, which is totally possible. Explanation is that you're going to say that the heat expands the gas, and the pressure will increase. And therefore pressure will increase. Now, this is only 1 mark, so you don't really have to explain how pressure increases. But if it was more than 1 mark, and if there were several lines, you can just say that, particles move faster, they collide more frequently with each other and with the wall, and therefore the pressure increases.